Simple harmonic essence of cantilevers. Raccaria apparatus. Long wooden scale. Slotted weights. A Z clamp. Star clamp. Vernier calipers and screw catch. First of all, the wooden beam fixed one end by Z clamp, the other end connected mass. Initially, find length of the cantilever, distance between mass to Z clamp. Then add 150 grams of by mass. It's for M1. Find 10 number of oscillation. Calculate timing periods. Reading value noted is a trial 1. Again try trial 2 for 150 grams. The trial 2 having the same 10 number of oscillation corresponding timing periods noted. Finally, we calculate mean value and one number of oscillation recurring timing periods. Next, we add again 150 grams loaded. Here total load is 300 grams. Now the same calculations, the 10 number of oscillations corresponding timing periods. Again, to try trial number 2 for 300 grams, 10 number of oscillation corresponding timing period. So this value noted tabulation. Find mean value and one number of oscillation recurring timing periods. Next, we find thickness of the cantilever using screw gauge. Initially, we find 0 error, 0 corrections of screw gauge. That value noted, and you measure the thickness of the bar for 5 places. Here the screw gauge having two number of scales, pitch scales reading and head scales reading. Pitch scales each division says 1 millimeter. The head scales having 100 divisions. So here least count is 0.01 mm. Finally, the find number of readings or tabulator, getting the mean value of thickness of the bar, noted. Next, we find breadth of the bar or cantilever using vernier caliper. Here, the vernier caliper, zero error, zero correction. In this case, for 0, we find only MSR value and vernier scale coincident divisions. The same calculations, you have to find 5 number of places, calculate or measure breadth of the cantilever. So this value or tabulator, finally we find mean value of breadth of the cantilevers. So these values are tabulator and using calculation. Here the breadth of the bar and the thickness of the bar by tabulations. For vernier caliper readings, but the main value is 2.62 centimeter or 10 to the power minus 2 meter. And thickness of the bar using screw gauge, initially we find 0 error, 0 corrections value. Here the vernier screw gauge 0 error is minus 77 division. The correction is plus 77 into least count. The answer is plus 0.77 millimeters. Finally, screw gauge values are added, 0 corrections. Here there's a 5 number of thickness of the bar values. Get the main value is 7.494 millimeters. Here the main tabulations of cantilever. The length of the bar or length of the cantilever, the distance between Z clamp to that length of cantilever, L is equal to 94 centimeters. The mass M1 is 150 grams or 0.15 grams. Here the trial 1, trial 2, 10 number of oscillation mean values, and time for 1 oscillations, that is value for T1 0.575 seconds. And try mass M2, we add again add 150 grams. Total mass is 300 grams, so 0.30 kg. And trial 1, trial 2 for 10 number of oscillations and get the mean values. Finally, we got it for 1 number of oscillation T2 0.725 seconds. So these values are tabulator calculator. M2 minus M1 divided by T2 square minus T1 square. The M2 is 0.30, M1 is 0.15 divided by T2 square minus T1 square's value. Finally, got it, the answer is 0.7692 kg seconds per 2. The Young's modulus of the cantilever formula is E is equal to 16 pi square L cube. M2 minus M1 divided by B D cube into T2 square minus T1 square. Here M2 minus M1 divided by T2 square minus T1 square is tabulations values. So that value is separator 0.7692. The remaining value is 60 pi square L cube divided by B D cube values. Here that values are right here. Get the mean value is 0.9140 to plus 10 Newton by meter square. It's a Young's modulus of the cantilevers.